The Geminid meteor shower, always a favorite among the annual meteor showers. 2023 will be a great year for Geminid meteor shower viewing as it peaks around the time of the new moon, when there is no interference from moonlight. Skywatchers can see up to 150 meteors per hour at peak times according to the American Meteor Society. In zenithal hourly rate is calculated 120 meteors per hour. The bold, white, bright Geminids give us one of the northern hemisphere's best showers, especially in years when there's no moon. They're also visible, at lower rates, from the southern hemisphere. The meteors are plentiful, rivaling the August Perseids. The Geminid meteor shower is nearly 200 years old. According to known records, the first recorded observation was in 1833 from a riverboat on the Mississippi River and is still going strong. In fact, it's growing stronger. That's because Jupiter's gravity has tugged the stream of particles from the shower's source, the asteroid 3200 Phaethon, closer to Earth over the centuries. The shower owes its name to the constellation Gemini because the meteors seem to emerge from this constellation in the sky. By determining the position of this radiant point on the sky, it is possible to work out the orbit of the stream giving rise to any particular meteor shower. It is sometimes even be possible to identify the particular body responsible for creating the debris stream, if there is a known comet or asteroid with a very similar orbit. At its peak, the shower is expected to produce a nominal rate of around 120 meteors per hour, ZHR. However, this zenithal hourly rate is calculated assuming a perfectly dark sky and that the radiant of the shower is situated directly overhead. In practice, any real observing sight will fall short of these ideal conditions. The number of meteors you are likely to see is thus lower than this, and can be estimated using the ZHR formula. Unlike a majority of the meteor showers we experience on Earth, the Geminids are the product of an asteroid. The reliable shower produces bright meteors associated with the asteroid Phaethon, a strange blue rock that acts like a comet. The Geminid meteor shower will be active from December 4th to December 17th, producing its peak rate of meteors around December 14th. 3200 Phaethon was discovered on images taken by infrared astronomical satellite on October 11, 1983, by Simon Green and John Davies. Initially named 1983 terabytes, it was given an asteroid name, 3200 Phaethon in 1985. After the orbit was calculated, Fred Whipple announced that this asteroid has the same orbit as the Geminid meteor shower. This was very unusual, since an asteroid had never been associated with a meteor shower. It is still not known how material from the asteroid's surface, or interior, is released into the meteoroid stream. 3200 Phaethon gets very close to the Sun, half the distance as is the innermost planet, Mercury. Then it ventures out past the orbit of Mars. So the meteor material intersects the Earth's orbit every mid-December, hence the Geminid meteor shower. Meteor showers arise when the Earth passes through streams of debris left behind in the wake of comets and asteroids. Over time, the pieces of grit-like debris in these streams distribute themselves along the length of the parent object's orbit around the solar system. Shooting stars are seen whenever one of these pieces of debris collides with the Earth's atmosphere, typically burning up at an altitude of around 70 to 100 kilometers. On certain days of the year the Earth's orbit passes through particularly dense streams, associated with comets or asteroids which have vented particularly large amounts of solid material to space, and this gives rise to an annual meteor shower. Such showers recur on an annual basis, whenever the Earth passes the particular point in its orbit where it crosses the particular stream of material. What's the difference between a comet and an asteroid? A comet is a dirty snowball, with a solid nucleus covered by a layer of ice which sublimates, turns from a solid to a gas, as the comet nears the Sun. Comets are typically lightweight, with a density slightly heavier than water. They revolve around the Sun in elongated orbits, going close to the Sun, then going far from the Sun. Seen through a telescope, a comet will show a coma, or head of the comet, as a nebulous patch of light around the nucleus, when it gets close to the Sun. But when seen far from the Sun, most comets appear star-like, because you only the nucleus. An asteroid is a rock. Typically, an asteroid's orbit is more circular than that of a comet. Through a telescope, an asteroid appears star-like. These definitions worked well until a few decades ago. Larger telescopes began discovering asteroids far from the Sun, and some of these objects, as they approached the Sun, grew comas and tails, requiring the change of designation from asteroid to comet. For example, an odd object named Chiron, considered an asteroid when discovered in 1977, was reclassified as a comet in 1989 when it showed a coma. It orbits the Sun every 50 years and travels from just inside the orbit of Saturn to the orbit of Uranus. So an object initially considered an asteroid can be reclassified as a comet. Then, can the opposite occur? Can a comet be reclassified as an asteroid? Yes, it can. It is possible that a comet can shut down when its volatile materials become trapped beneath the nucleus surface. This is known as a dormant comet. When the comet loses all of its volatile materials, it is known as an extinct comet. The asteroid 3200 Phaethon seems to be an example of either a dormant or an extinct comet. Gemini is fairly easy to spot in the night sky as it is located northeast of the constellation Orion, between the Taurus and Cancer constellations. The two brightest stars in the constellation, Castor and Pollux, represent the heads of the Gemini twins. To best see the Geminid Meteor shower, go to the darkest possible location, lean back and relax. You don't need any special equipment like telescopes or binoculars, as the secret is to take in as much sky as possible and allow at least 30 minutes for your eyes to adjust to the dark. Avoid using your phone and make sure you have the red light setting on flashlights to preserve your night vision.